This is a chapter, lesson 2.1 recording of the language of algebra. So we are starting a new unit, and in this unit we are going to just do a little bit of, we'll just do a little bit of a review of the algebraic terms. So the first thing that we're going to do is we're going to look at the exponents. So in exponential notation, we use exponential notation as a shortcut for multiplication. So if you see right here, you can have, you can multiply number 11 3 times by itself, and that's kind of a long way of doing it, or you can just use the exponents to write that multiplication. So in an exponential notation, let's say we have, so we're going to use 11 to the power 3. Right? In this exponential notation, the actual number is called the base. And the number that's being raised to power, the power is your exponent. So there's two parts to this, to the exponential notation. There's the base number, and then there's the exponent. Base is the number being multiplied. And the exponent is how many times. Okay. So if I multiply 11 times itself 3 times, I'm essentially raising 11 to the third power. All right. So here's a couple of examples here that we have. You have the exponential notation of, you have your 7 squared. That means 7 to the second power, or 7 squared. And if I were to write that as a multiplication problem, that would be 7 times 7. 5 to the power 3 is read as 5 to the third power, 5 cubed, or 5 times 5 times 5. Then we have 9 to the fourth power. So that means 9 times 9 times 9 times 9. So the 9 is being multiplied. 4 is how many times? At the end, 12 to the fifth power. You can also write that as 12 times 12 times 12 times 12 times 12, 5 times. All right. All right. So the first skill that we're going to try is writing, knowing that you have these, now that you know these exponential rules, we need to write each exponent, each of the following problem using exponents. All right. So in those type of problems, you are going to look at the number being multiplied. So that number, you are going to keep that number. So we have 7, and we multiply 7 5 times. So that means 7 raised to the power of 5. You can apply the same rules to the variables. So here we don't know the number, we're just using the variable. So x is still the base, and x is being multiplied by itself 4 times, so it's x to the power of 4. We can mix and match different numbers. So here we have 2 bases in part C. We have the 5. Right, so this is my first base, 5, and I'm multiplying that 5 by itself 1, 2, 3, 4, 5 times. And then I'm going to use the multiplication symbol because all of this is still a multiplication problem. The next base is 10, and I'm multiplying that 10 by itself 3 times. So 10 to the power 3. Right. So from writing, the next skill is evaluating exponential expressions. So here we are. Evaluating exponential expressions, you just basically multiplying. So 4 squared is the same as 4 times 4, or 16. 2 to the power of 6, you would multiply 2 6 times 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So we have 8, 16, 32, 64. So that would be 64. You would actually just basically multiply. So remember, 2 to the power of 6. This is a very common mistake. This is not 2 times 6. So that would be wrong. So that is not this. Okay. All right, so the next one is 3 to the power of 4. And again, think of the 3 multiplied by itself 4 times. So 3 times 3 times 3 times 3. So that would be 81. Okay. Now the tens. So the next series of problems are going to deal with tens. Tens are pretty easy because of the zeros. All right. So 10 to the power of 2 means 10 times 10, which is 100. 10 to the power of 3 would be 10 times 10 times 10, which is 1,000. And then 10 to the power of 7. So let's look at the pattern here first. So 10 to the power of 2, you have the 2 exponent, you have 2 zeros. You have the 3 exponent, you have 3 zeros. So for 10 to the power of 7, I don't really need to multiply. I have the exponent 7. That means I have the 1 and the 7 zeros. 2, 3, 4, 5, 6, 7, and then just break your periods. So you have 10 million here. Okay, so the next concept in this lesson 2.1 is order of operations. A lot of you know, probably know PEMDAS. We use GEMS, trying to step away from PEMDAS because what we have noticed, because in PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. So we have a whole generation of students growing up believing that multiplication always comes before division because that's what the acronym PEMDAS stand for. So we stepping away using GEMS. GEMS stands for order of operations. So we're going to start with grouping symbols. So it's any kind of parentheses, square brackets, absolute value. Sometimes the grouping symbols are square roots, but that is beyond the extent of the scope of this class. Okay, so any kind of parentheses. The next one is exponents. Then M stands for multiplication or division. So or is very important here because that means one or the other, whichever one comes first from left to right. And then the last one, the F, the S stands for subtraction or addition. And again, or is very important here. And that means that it is, you're going to go look at your problem and from left to right, whichever one comes first, that one gets carried out first. So why do we need order of operations? We need the order of operations when we have more than one operation present in a problem, and we need to choose which one to do first. So then we would go through this list and see which one we have. And if we have the grouping symbols, we'll do them first. If we have exponents but no grouping symbols, we'll do exponents. If we have to choose between multiplication or addition, or multiplication or subtraction, we'll choose multiplication first, and so forth. The order of operations allows us to choose the order in which we actually performing operations on the numbers. So let's go ahead and see how the order of operation works in a particular problem. So we have a couple of problems to evaluate. The first thing that we're going to do is look at the first problem and go down through your list. Grouping exponents, multiplication or division, subtraction or addition. So we do not have any parentheses, so we do not have any grouping symbols. The next question to ask yourself, do I have an exponent? And the answer is yes. So because we have an exponent, that operation is going to get done first. So we're going to do 3 to the power of 4. All right, so we're going to evaluate 3 to the power of 4, which would be 81. And then we rewrite the problem, 12 plus 12 divided by 3. Okay, so now we're looking at the next line, and we're asking ourselves again. We have the addition, we have a division, so I have more than one operation present. I need to make a choice, which one gets done first. All right, so I'm going to look at my order operation, and I have multiplication and division comes first before subtraction or addition. So the next part that I'm going to do is 12 divided by 3. So the one is going to get done first, second. So I have 81 plus, and then 12 divided by 3 is a 4. And then at the last step, I only have one operation, which is 81 plus 4. So I can go ahead and do that, and that would be 85. And that is our official answer for this problem. Okay. I strongly encourage you, if you are a little bit shaky in order of operations, keep rewatching these videos, play them back, and like until you get comfortable with choosing which step to do next. Okay, so here's the next one, part B. We have a lot going on there, but the main thing here is that we do have parentheses. We have multiple parentheses. So the first thing I'm going to do is I know I have parentheses, so I need to do what's in parentheses first, so which is basically all of this. That's what's in parentheses and needs to get done first. Okay, so then because there's more than one thing going on in parentheses, I have internal parentheses, so I have the other one. So I'm going to get this one done. I'm going to get the second parenthesis done, and then I'm going to do the subtraction. All right, so that's my plan. Let's go ahead. So when you have a parentheses in your problem, you're going to work from the outside in until you get to the one operation that you will absolutely do first. So here I'm doing the 10 minus 4 first. Okay, so here we are. So 10 minus 4 is a 6. All right, so I have 3. I have my square bracket minus, I have not done 5 minus 1, so I'm going to copy that down, keep the square bracket to the power of 2. So the only thing that got done is the very first parenthesis. Okay, now I'm going to do the second one. Okay, I still have not cleared all of the parentheses in, so I have to start with the innermost. All right, so I have 3, my bracket, 6 minus, and then 5 minus 1 is going to be a 4. All right, still inside the bracket. Okay, so now I only have one operation inside my brackets, so now I'm going to get this part done right here, 6 minus 4, and then I'll move on. So 6 minus 4. All right, so now I get to do 6 minus 4. So I will have 3. Do not leave the brackets. Do not drop the brackets yet because of the exponent. So we have 2 to the power of 2. All right, So the next part I'm evaluating. I have multiplication 3 times. So I have multiplication and I have an exponent. Exponent gets done first. Okay, so I'm going to do this part right here. Okay. 3 squared. All right, so 2 squared is a 4. So I have 3 times 4. And I am finally down to one last operation, which is multiplication. And now I can say 3 times 4 is 12. And my problem is done. Something that I have done while I was working up the problem out, and that was part right here. Notice that you did not have an operation symbol between the 3 and the brackets. If the operation symbol is missing, that means that it is implied multiplication. So implied multiplication. All right, we use multiplication so often that sometimes we just omit that little dot. Okay, so next problem, part C. Here we have a couple of things going. We have the numerator and we have a denominator. So we will do them one after another. So the first thing I'm going to do the top, which is the numerator, and then I'm going to do the bottom, which is the denominator. Okay, so let's go ahead and do that. So let's look at the top part of this fraction. What's happening in the numerator? And in the numerator, I have subtraction right here, and I have division. All right. So in my handy dandy chart for my orders of operations, I have grouping symbols, exponents, multiplication or division, subtraction or addition. All right. So I have division. So I have division and I have subtraction. Division gets done first. Okay. So on top of this, I have 12 minus, and then 16 divided by 8 would be 2. And I have 15 divided by 3 on the bottom. All right. So now I have one operation on each top and bottom. So I'm going to do 12 minus 2, which is going to be 10. And then 15 divided by 3, which is a 5. So I have 10 in the numerator, 5 in the denominator. Okay, and I can actually treat this as a division problem. 10 over 5 is the same as 10 divided by 5, which will give me 2 as the result. All right, and then I think this is our last problem, part D. Yes. So one more problem with order of operations. We don't have, in part D, we do not have any parentheses. So let's go ahead and, but we do have 1, 2, 3, 4, and 5 operations. So we have a lot of choices to make. So we have subtraction, division, multiplication, we have exponent, and we have another subtraction. So 5 operations. All right, so let me clear it out so it's not bothering us. Let's go ahead and decide on the first step. Again, go through your gems. You do not have a grouping symbol, but you do have the exponent. So exponent, this part right here, is going to get done first. So I'm going to copy 225 minus 48 divided by 8 times 3 squared. 3 squared is 3 times 3, which is 9. So I'm going to write 9 in there, minus 17. Okay. That is the only thing that is done on the second line. And now I'm going to examine my problem again. So I have subtraction, I have division, I have multiplication problem, and I have a subtraction. So here's the part that I'm going to be working on next. Okay. So I have division and I have multiplication. They are on the same equal importance, and whichever one comes first gets done first. So I'm going to go for division because that one is on the left side. So 225 minus 48 divided by 8 is a 6 times 9 minus 17. Okay. So with every step of the way, the problem gets smaller. So now we're down to 3 operations. I have subtraction, multiplication, and another subtraction. So the next part I'm going to I'm going to do is the multiplication. All right, so for multiplication, I have 225 minus 6 times 9, which is 54, and then the minus 17. Okay. So only 2 operations now, and they are subtractions. So I'm just going to go and do them. I have no decisions to make. I'm just going to go do them in order. So I'm going to do 225 minus 54, and that should give me 171. So the next one is 171 minus 17, and that would be 154. All right. All right, and that is all for lesson 2.1.